Hey everyone, today we are going to solve supplementary problems in chapter 3, total hydrostatic force on surfaces. So we have problem 3-104. Water in a tank is pressurized to 80 cm mercury. Determine the total force per meter width on a panel tank. So we have here our given. So we have the height of our mercury, which is 80 cm, and we also have the given for the height of our water in our tank, which is 2 meter, 4 meter, and the height for our A to B, which is 3 meter. And identifying our given, we can now solve this problem. So in our problem, we are asked to determine the total force per meter width on a panel tank. So we are going to solve first for the pressure of our tank. So to solve that, we are going to use this figure. And we assume that if it is going downward, it is positive, and if it is going upward, it is negative. So we have here PT, or the pressure of our tank, plus the pressure of water. This one is cancelled since same type of fluid and same height. So we have pressure of our tank plus pressure of water minus the pressure of mercury is equals to 0. Transposing this one to get the value of our PT, then we will have the equation PT is equals to negative pressure of water plus pressure of mercury. So the formula for pressure is specific weight times height, and the formula for specific weight is density times gravity. Then we will have now the equation PT is equals to negative pGH of water plus pGH of mercury. Then substituting our given to our equation, then we will have PT is equals to negative times density of water, which is 1000 kg per meter cube, times gravity, which is 9.81 meter per second squared, times the height of water, which is 2 meter, plus density of mercury, which is 13,600 kg per meter cube, times gravity, which is 9.81 meter per second squared, times the height of mercury, which is 80 cm, converted to meter, which is 0.80. Then we will have now the value for pressure of tank, which is equal to 87,112.8 Newton per meter squared. We can now proceed in solving the pressure acting on gate A and B. To solve that, we will have the equation PA over B is equals to PT, which is the pressure of our tank, plus pressure of water. So since the formula for pressure is pGH, then we will have the equation PA over B is equals to PT plus pGH of water. So we will now substituting our given in our equation, then we will have PA over B is equals to 87,112.8, which is the value of pressure tank, plus density of water, which is 1000 kg per meter cube, times the gravity, which is 9.81 meter per second squared, times the height between the center of the gate to the top of the tank, which is 7.5 meter. Then we will have now the pressure acting on gate A and B is equals to 160,687.8 Newton per meter squared. So now we can proceed in solving the force or the total force per meter width on a panel of the tank. And to solve that, we are going to use the formula for pressure, which is pressure is equals to force over area. Then multiplying both sides by area, then we will have force acting on the gate A and B is equals to pressure acting on A and B times the pressure times the area of our gate. Then we will have now FA over B is equals to 160,687.8 Newton per meter squared times the area, which is length times width. Then we have now 3 meter times 1, which is the width. Then we will have now 3 meters squared value of force acting on gate A and B is equals to 482,063.4 Newton. Converting it to kilonewton, then we will have now the force acting on gate A and B is equals to 482.06 kilonewton.